All right. Welcome to today's web tracks entitled Future SOC Codify and Automate, presented by Andrew Plato. A webinar that is being presented today by the Upper Midwest Security Alliance, or UMSA. Hello, my name is Marie Strauser. I am the UMSA Managing Director, and I'm your moderator for today's presentation. During the webinar, you may submit your questions for the presenter at any time using the chat feature. So if you go down to your chat box on the side, you can type in your question. Our presenter will respond to the questions at the end of the webinar. We are recording today's webinar for later availability on the UMSA website. So now I'm just going to give a good old welcome, Minnesota snowy welcome to Andrew. Andrew, I forgot to mention it's snowing here in Minnesota today. For those of you that aren't here, we're enjoying a nice white afternoon here. So welcome, Andrew.
Well, good morning and thank you, Marie. I actually heard that some schools were closed because of the snow, which I can't, is that true? Does that ever happen in Minnesota? I thought you guys never closed schools. So.
Yeah, yes. Those of us that are probably on the phone are like, when I was a kid, we never closed school.
Well, everybody, thank you for coming today. I really appreciate you spending your snowy day with us to talk about codifying and automating security and what the future SOC is going to look like. So why don't we go ahead and jump right in. My name is Andrew Plato, and I am the CEO of Anitian. Anitian is a 23-year-old security firm. We have done a little bit of everything in security, but we are really big into the cloud and automation. And I'm going to talk a lot about the cloud and automation today because we're going to start by conversation about kind of why security isn't really working, why the traditional methodologies are failing us. But then what I really want to talk about today is a strategy for codifying your security architectures. The ultimate takeaway today, what I want you to leave this webinar with is some good, solid concepts and strategies around codifying and automating security in the cloud. This, like many of the topics, is a big topic. There's a lot to talk about. We could spend literally weeks going through this. So I want to hit some big issues and give you some good ideas so that as you go into your organizations and work through this, you have some of those concepts, ideas, and strategies to work with your team and get yourself ready for either this. If you've already started this voyage to the cloud, then some of the concepts I'm going to talk about will be very familiar. But if you're new to it, this will help guide you down that path. But I want to start with this image, this dude looking into the sky. Since for as long as I can remember in security, there's been this dream we've had of security by default and by design. And what I mean by that is if you've been in information security for any length of time, we've always had this dream that systems, networks, architectures, applications would have security integrated directly into them. It wouldn't be an add-on. It wouldn't be something that you would slap on top later on. It isn't something that a risk assessment necessarily would force you to do or compliance would force you to do. That security would be enabled by default and that it would be baked right into the design of the system. Now, the problem is that this has been basically just a dream. It's not a reality. The reality, as many of you I'm sure already well know, that security is something that is slapped on at the last minute. So let's dig into that problem. Why is that? Well, the traditional security concept, right, is that you have a team, you have people, and you have process or policy documents, and then you buy a bunch of products and controls, right? So that's your sort of traditional classic. I'm sure you've seen slides like that. There's other ones, you've seen maybe versions of the cycle, the wheel of death here of, you do a risk assessment, you implement controls, you test them, and you remediate issues. There's nothing fundamentally wrong with these generic concepts about security, but, yeah, that's just not how things actually are working in today's businesses. The reality is people don't care about security. It's an annoyance to them, particularly when you want to talk about compliance. Compliance is nothing but an impediment to many organizations. It's miserable. It takes time. It's time consuming. It's very unrewarding work. The policies that we're writing, if any of you have seen my presentations on writing policies, most policies at most organizations are completely unreadable. They're miserable dirges of blathering nonsense that nobody really can relate to. And the technologies, for all the technologies we have, they aren't working. And I don't need to go any farther than every single breach that's happened. I always point out that every company that's had a major breach in the last 20 years had a next-gen firewall or a firewall. They had endpoint security. They had these deep, dark web scanning threat intelligence, artificial intelligently massive, mega cool tech. They had all the tech, and it didn't stop the breach. So the tech, the policies, and it's not working. If you put it in a different format, a lot of organizations have this antagonistic relationship with security and their developers. And what the outgrowth of that often is that security teams often wind up doing things that really don't move the ball forward. So in our experience, and this comes from many of our cloud partners as well, the number one thing that grinds compliance projects down is not compliance. It's not the intricacies of FedRAMP, the NIST frameworks. It's not the nuances of PCI and how they require encryption or the use of higher TLS protocols. That is not the problem. The problem is companies waste extreme amounts of time arguing over which piece of technology to buy. They spend months, if not years, looking at SIEMs and thises and that's and evaluating all this technology, and it doesn't move the ball forward. And so you wind up in kind of this cycle of death, and it isn't working. The problem is us, quite frankly. We, human beings, are the reason for all these problems. Now, I know it's hard to hear that. Some of us don't want to hear that. Like, what do you mean, I'm the problem? It's not you personally, although it might be, but it's not you personally who's the problem. It's just us as humans. And us security people have quite frankly been put into a position that is just no longer viable. It starts with the expectations that are put on us as security professionals. We now, as security people, often live in environments where we are expected to behave and perform at the speed, scale, and perfection of computers. And that is insane. We are now telling security people, you need to know everything that's going on. You can't miss a single thing. You need to be aware of every inconceivable risk, threat, problem, patch issue that ever could possibly exist in our enterprise. And if you miss a single thing, one tiny little detail that causes a problem, we're going to roast you alive, humiliate you in public, and fire you. And that is a ludicrous expectation to put on any human being. But then the reverse problem here is that not only are we asking our people to do ludicrous work, but then we're also expecting the machines, the technologies, to do all the thinking for us. This is really why you have this outgrowth of all this AI tech and all these technologies that you see in RSA or all these shows. Is they're all coming in and saying, hey, you don't need to worry, we've got it all taken care of. You plug our box in, you're good to go. And we're expecting the machine to solve the problem for us and figure out everything about our business. And for the areas where the machines and the humans, then we're like, well, we'll write policies and we'll just fill in all the gaps. You see, the real key problem and the reason why this isn't working is that basically we're putting everybody in the wrong places. We're making people do the work of machines, machines do the work of people, and process is being used as a weapon or policy is being used as a weapon rather than something that can actually build trust, which is what processes are good at. And it starts by an understanding of in your organization of understanding what people are good at, what technology is good at, and what processes and what its purpose is. Us human beings, we're good at analytics. We're good at solving complex problems. We're also good at having goals and vision. We are not good at discipline. We're inconsistent. We're unreliable. We're slow. We're often drunk. I'm not drunk now. And then technology is consistency, reliability. That's what it's good at. So let's talk for a second about really what makes great security in an organization, because, okay, yeah, got it. We're the problem. But what really is great security? I've believed for a long time that great security is ultimately the fusion of three basic principles. Go, CIA and all the sort of classic security stuff. But when you really kind of boil it down, it's all about having a vision, being agile, and having discipline. Let's talk about what each one of those are in a little depth. Vision is all about having a goal, knowing what your mission is. Now, this is the area where most security people, I think we're pretty good at vision. We know what we're set out to do. We know what our purpose is. We know we're there to protect the business. The vision of security is, quite frankly, pretty easy for us to all comprehend as a industry, as a people. It's also something that we as people are pretty good at. We're good at communicating our visions and our goals, and this is something we can do well. And you need that. Good security needs that clarity of goal, clarity of mission, clarity of focus on what it is we're trying to accomplish. Without that, no organization would function. So vision is not unique to security, of course, but it is vital to keeping us as security professionals on target. But agility is the other key thing. This is something that's proven over and over and over again over the last many decades, that in order to deal with the threats of today, we have to be able to move an organization really quickly. And I mean way quicker than you think. So you look at modern, high-performing companies, the Netflixes, the Ubers of the world, these super high-performing companies. These are companies that can implement thousands, if not tens of thousands of changes in a single day. A lot of people like to hold up Netflix as an example of this, and they're a great company. They're actually, their whole sort of process in DevOps and their CI/CD pipeline is really a model for companies, and they're not alone. There's plenty of companies who have great practices like this. What has allowed Netflix really to be so high performing is because of that ability to change, and change with extreme speed. They don't have to go through a 6-month change board review. Changes just happen. For security, this is crucial. If you can't change, and change really fast, and change with consistency, you can't be secure. It becomes practically impossible to secure an organization that is stuck in a static, never do anything, never move mentality, because that essentially creates a culture of stagnation, and you're basically waiting to get hacked, because stagnation is going to work. You have to be able to adjust to threats. You have to be able to deploy new controls. You have to be able to secure things. So agility is unbelievably crucial, but discipline is the thing that makes it all work. You can have all the grandiose vision in the world, you can have all the great agility in the world, but if you can't form discipline in an organization, you'll also never be secure. And there's a reason I put a picture of U.S. Marines up here, because I didn't serve in the military, but I know enough about that, and know people who have. And one of the key things about serving in the military is the discipline. Now, that's what makes Marines effective as a weapon, as a tool, as a fighting force. That discipline is crucial to their ability to function. Incidentally, agility and teamwork are also crucial. So if you're figuring it out, there's a lot of similarities between how fighting forces work and how information security works. But discipline is a root issue. You can't be a Marine, and you can't be an effective Marine or any soldier for that matter unless you have that discipline. Well, guess what? This is not something we humans are good at. I personally have very little discipline, which is probably why I never served in the military. Discipline is just not our thing as human beings. It's something we fall down on a lot. So you get to this notion of you want to have good security, you need clear goals, you need the ability to adapt, and you need consistency and repeatability, the discipline. The future security, the security operations of the future, is not going to be a data center full of gear. It is not going to be large, massive teams of security guys and gals sitting at computers watching sims. The security of the future is really based on a DevOps model. It's where we are fusing people, code, and a DevOps process together. Because these three things, sorry, I flipped a little early there. These three things form what is a future security operations. People doing the analysis. DevOps is the process that holds it all together, and code is the discipline. And I'm going to talk more about that as we go forward. Now, I jumped ahead and I gave you this slide, but we already have a lot of this already baked and ready for us to use, and that's the cloud. The cloud gives us this model by default and by design. The cloud is based around that model. The cloud is all about a DevOps methodology, code as the basis for everything, and people taking a completely new role in that relationship. And this is why we say security really is better in the cloud. It isn't just easier. It isn't just more consistent. It is fundamentally better when you put security in the cloud. Okay, what does that really mean, right? Sounds great, wonderful, cool, sure, whatever. Sold on that idea. Now let's talk about what I really mean by that. Let's get to this last section. Let's start with what I think is probably the most profound issue that any of us or any of you are going to face over the next, if you're not facing it right now, you will be facing it very soon in your organization, which is the times and the teams, they're changing. 10 years ago, DevOps, developers and stuff, it was kind of this random concept. Didn't see it that often in organizations. Just in the last few years, I've witnessed myself in organizations, DevOps is rapidly becoming the central part of almost every high-performance IT shop. The classic model in the past was you kind of have these siloed specialties, right? You had your network admin, you had your systems admin, you had your developers, you had your release people, you had a database administrator, which, by the way, I have no idea who these people are. Okay, I just grabbed this picture off the internet. If you know any of them, tell them thank you for lending me their picture. I just thought they were a perfect looking team. That's the classic IT / team, right? And you'd sometimes add a security person at the end of that group. That's an antagonistic model. Okay, that's a model where it's naturally oriented around segmentation and isolation and antagonism between each of those groups. The network admin is, my network runs, I don't care about anything else, right? The programmer, all he cares about is the code. Hey, my application runs, I don't care about your network. In the traditional world of IT and security, this antagonism doesn't work. It's what leads to static castle mentality. It's what leads to security being slapped on at the end. This classic structure of an IT team is disappearing, and it's disappearing rapidly. If you are in one of these, I would strongly encourage you to get into DevOps coding and development of some kind. Because what I've noticed in most organizations is slowly but surely, DevOps is just consuming everything. So this is the first big change that's happening. The organizations are moving to DevOps for a variety of reasons, the least of which being is that there's simply more it's a more dynamic way to implement security controls and controls in general. Let me get to the next key thing that's important to this, which is leadership. In order to move to a codified DevOps world, you really need to have leaders that understand this and understand the concepts behind it. Now, the whole leadership conversation is really almost a presentation in and of itself, and I'm not going to go down that pathway too much. What I am going to say is this, is that the security team of the future is not a team that is obsessed with hacking or obsessed with saying no or obsessed with enforcing controls. The security group of the future is integrated into everything. Security is an integral component into every piece and part of the organization. And security is driving deeper and deeper into those organizations and working collaboratively to create environments that are secure by default and by design and enable developers to develop and deploy in a secure manner. Security teams are enablers, they are not enforcers. What that really means too is you've got to reverse the mentality of focusing on hacking, technology, and just checking off compliance. And that requires leadership. It requires seeing the future and understanding that this is the direction you're going, and that you got to quit obsessing over every infinitesimal hacking technique and focus on how can we build environments that will provide a baseline for developers to build on top of. Because once we can build these secure environments in the cloud and repeat them over and over again, you now create a structure that is inherently secure. It doesn't require constantly berating people to follow the right practices. But this starts with leadership. Puppet does a great document every year. They call it the State of DevOps. Their 2017 one, which is admittedly a couple of years old now, is excellent because it talks all about this. In fact, that's where I got that this diagram from. And I encourage all of you to go read that because it talks in much greater depth about what is required at that leadership level to really adopt this. And what it boils down to is really adopting DevOps as a methodology really across the entire organization. You see, the thing about DevOps, we've all seen this diagram. If you haven't, then you're living under a rock. This diagram has been around forever, and DevOps as a concept is actually fairly straightforward. Is that you're integrating the development, the deployment, everything is done as an integrated whole rather than these silos. Well, guess what? Security has a role at every stage along that. And in order to get at every stage along that, security has to up your game. You can't roll in at the 11th hour and say, hey, this is all insecure. You can't do that, you can't do that, you can't do this, that's wrong, that's bad, no, wrong, bad, bad, bad. Because every person in that room is going to hate your guts. Because they've been working for months on this new product, and to have a security person roll in at the 11th hour and tell you everything is wrong, I don't care how right you are, nobody is going to like you, and nobody is going to listen to you. So you have to be integrated into this entire process. But you can't just walk in and say, well, I need to be integrated into everything. Integrate me. It doesn't work that way. You can't just demand to be integrated. You have to actually integrate yourself. And what we mean by that is that, number one, you got to leave the past in the past. You've got to let go of a lot of classic mentality around security. And that begins with, you don't just lift and shift. Whenever somebody says, well, we're going to lift and shift our security into the cloud, that never, ever, 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 ever works. Don't do it. It doesn't work. And you're not going to be the first company to figure out the miracle of lift and shift because it simply doesn't work. Whatever you've done on-prem does not translate to cloud infrastructure. And I know exactly what a few of you are thinking. Well, now wait a minute. So-so vendor and so-so vendor tell me I can just move on. Yeah, of course they're going to tell you that because they want you to keep using that piece of equipment you bought in the cloud. And of course they have a cloud version. And I'll pick specifically on the next-gen firewall market here. There is actually almost no reason to deploy a next-gen firewall in the cloud. You don't need them. Now, if you go talk to your next-gen firewall vendor, I guarantee you they're going to have a completely different opinion than I do. They're going to tell you, oh, you absolutely got to have it. How can you be secure? You can't be secure and compliant without a big next-gen firewall. Wrong. You absolutely don't need one. In fact, next-gen firewalls are an impediment to security in the cloud because they create architectural complexities that are unnecessary. Now, that's a whole debate in and of itself. I'm not going to go too far down that pathway other than to say that's a good example of how you've got to just let the past go. You've got to stop falling for this sunk cost fallacy, this notion of, but we've already invested all this money in, Palo Alto boxes. So what? I'm sure there's people who invested tons and tons of money in the buggy whip industry around the turn of the century. And guess what? That didn't do them any good either. And don't get me wrong, I'm not trying to say next-gen firewalls are useless. What I'm trying to say is that don't just keep using them because you feel like you have to. Now, the good news is a lot of the tools you're going to need for automation are already widely available to you. You don't have to go looking or seeking them out. These are, so I just listed a few right here. These are AWS's tools. AWS has a ton of native tools specifically to do automation in the cloud. All you got to do is learn them. And this is where I get to the last piece, the big piece, the bad news. I put the bad news right in the middle of all this. You got to code, okay? You've got to be able to code. In order to get into that DevOps world, you have to be able to either code or you got to be able to work within that code. You got to be able to work with this DevOps mentality. What that means is that, and I just threw this image up here. This is some of the classic kind of DevOps technologies. You've got to understand these technologies. Now, maybe you're not going to necessarily become an expert in, Jenkins or Kibana or something. That's fine, but you got to understand the value of them. You got to understand how they integrate, and you got to understand how they can be used. Things like Ansible, Puppet, and Chef. These are exceedingly powerful security technologies, but they're not sold as security technologies. They're sold as configuration management. You need to know them. You need to understand how to build infrastructure in the cloud, doing things like CloudFormation scripting, Terraform, Azure's scripting language that they have. You got to know how to build those systems. You got to know how to read that. If you want to get into DevOps, if you want to get integrated into it, you have to be able to talk with DevOps people using their language. You can't walk into a room and start spouting off control framework rules and NIST this and dark web that and hacking that and expect to get respected. Because what people are going to do is go, yeah, whatever. Don't care. We're trying to build an app here. You have got to talk and work at their language. You've got to work inside their world, not expect them to come work inside yours. What that means is you're going to have to take all those controls and you got to turn them into code. Now, the great thing is that a lot of technologies you can do that reasonably easily. And that means is that you're not only turning that control into code, and notice I have a next-gen firewall up here, so if you want to use them in the cloud, you can. But you turn the deployment of that technology and control into code. And it's not just the deployment, it's the configuration of those controls. So you have to go beyond just deploying the firewall. You have to automate all of the configuration, which means you should be able to deploy a script for a next-gen firewall or a SIEM or whatever piece of control technology you need, that after that script runs, that tool, that program, that control, that whatever you need to run is pre-configured, ready to go. There is no manual configuration after the fact, or very, very little. That's the goal you're shooting for. You want to shoot for when the firewall's up and running, all the rules are already in it. All the certificates are already imported. All of the configurations, all the passwords, all the access rights, all of that is done, ready to go. Because if you can do that, you now have a baseline. You have a baseline upon which you can operate, something that you can give to developers and say, hey, you need to put a next-gen firewall environment? No problem. Here you go. Here's our pre-configured, ready to go, gold standard next-gen firewall for our organization. Here's the code integrated into your code. You're good to go. You need to deploy an endpoint agent. You give them the code. You give them the integration. You give them everything. You don't give them, hey, by the way, you've got to deploy this. You don't tell them they have to deploy them. You give them the code so they can just do it. You do that, now you're integrated. Now you're into everything. This is an example of code we actually wrote for our platform. This is a tiny snippet, very tiny snippet of how we automate the deployment of an Active Directory cluster. So when we deploy our platform, we have an automation product and platform. Part of the way we do that is to automate the configuration of the Active Directory. And this particular strip of code actually shows how we're adding and removing. And this is just this is basically a PowerShell script. It's just a big, long, complex PowerShell script. What it does is it not only deploys, and you can kind of see, if you follow along and you're familiar with PowerShell scripting, is basically it's adding these tools, it's including some of the features, it's importing certain modules into that, and then it's going through and creating names based on parameters that were passed to the script through another API. So essentially, you've got these parameters, count password, you'll see password in there, you'll see the domain DNS name. Those are all parameters that were simply passed to the script at runtime. So the script is written in a manner that you can basically pass in whatever you need to set up an Active Directory cluster to meet those criteria. And the number of parameters here is actually fairly limited. Our scripting for Active Directory only requires about 12 runtime parameters to build out a fully automated, fully configured, fully ready to rock Active Directory cluster isolated into its own cloud environment. You have got to be able to do this, or you've got to have a team that is capable of doing this. This is what the future of security is right there. That's what you're going to be doing in the future. You're not going to be fiddling with next-gen firewalls or arguing over PCI. You're going to be writing code like that. That's what all of us have to get comfortable with. What that allows you to do, as I've alluded to, is to automate deployments and create reference architectures. Once you have these reference architectures fully built out and ready to go, they can be deployed at a moment's notice. Your organization is going to deploy a new application. You should have a ready-made, right off the shelf architecture that you can supply the development team, and they can have it up and running in a few hours. That is the future security operations. It's not arguing over the SIEM. It's saying, oh, okay, you need to set up a new environment. Okay, here's the security stack. Here's all the controls you need. Here's the code you need. Go for it, guys. Develop your app. When you get close, when you get along the way, why don't I come in and I'll start running some scans and I'll get involved in helping you guys tighten that app down. That's future SOC. That's what security teams are doing in the future. I'm going to take an aside here, though, and I'm going to say, in order to do all this, you've got to log everything. This is a little bit of an aside point I have to make, but I've got to make this point. Data diminishes debate. One of the biggest problems in all of these teams and all security operations centers is you don't have data. You don't have data, you don't know what happened. You cannot prove something by a vacuum or by the non-existence of information. Okay, that's a fallacy, it's a logical fallacy, right? Okay, same principle. You cannot prove an attack happened if you have no evidence to prove that it happened. So you need data. And the only way to get data is to log everything. And when I say log everything, I don't mean log the things you kind of think are important. I mean literally logging every absolute last little tiny infinitesimal thing in the organization. Log every access requirement. Log every use of every credential everywhere, all the time, constantly, persistently, 24/7, without fail. What that really means is you're going to need a SIEM. You're going to need probably a couple of SIEMs, or you're certainly going to need a big SIEM. That is one of the technologies that's very valuable here. But it's not about having the coolest, greatest threat intelligence-y, most rad, massive console, diagram twinkling little SIEM. It's all about having the data in there so you can search it. It's more important that you have a SIEM that can log data than you have a SIEM that has a bunch of pretty graphs on it. The graphs are fine, they're great, but that's not as important as just getting the data out there. Now, here's the other thing. SIEMs are actually pretty inexpensive nowadays. In fact, you can do an Elastic-based SIEM for pretty much free. There's lots of SIEMs out there. You've got to log everything so that you can start mining that data for information. So that you can, when you ask the question, hey, did this application get hacked? It's not conjecture. Because what happens if you go to a developer and say, hey, developer, I think your app's been hacked. There's some crazy stuff going on. What do you think that developer is going to say to you? Oh, yeah, why don't we rip my code apart and investigate it in great detail? Why don't you fully scrutinize everything I've been doing for the last 6 months and tell me where I've failed? Do you think the developer is going to say that? Heck no, they're not going to say that. They're going to go, hey, it ain't me. I didn't do anything wrong. I know what I'm doing. I'm on top of everything. How dare you even think of me? And he's going to go around and get all of his buddies to try and agree with him. And suddenly you're going to look like the bad guy. But if you've got data and you've got a big, long chunk of data that says, hey, something's going on here, I want you to look at this data with me. What do you think? If you can get them invested in that process, then it's no longer an argument. Data diminishes debate. It's not a debate. It's, hey, something's going on. Here's the proof of that. Again, that's what the future of security operations is like. You're not going around to developers and going, hey, you're bad, you're wrong, bad, stop. No, don't. It's, there's an issue, let's work this together. It's a collaborative process, and you're using the tools and the technologies like a SIEM to aid you in that process rather than just be something that a compliance person requires. The other great thing about the cloud is guardrails. One of the beautiful things that's emerged in the last few years about cloud technologies is this concept of guardrailing, this ability to not only set up these secure by default and by design environments, but also use technologies. And there's a number of third-party tools. I have Cloud Checker as one. There's Evident.io, there's Dome9, and you can also build these yourself, by the way. AWS and Azure have huge libraries of guardrails. Guardrails are phenomenal because once you have an environment up and running, you run these guardrails on it. And what they do is they monitor the environment to maintain the configuration of that environment, to maintain all the correct access rights. So, for example, in organizations where we run their security operations, we have guardrails around, for example, this is one of many examples, but around S3 buckets. So, of course, you may have heard of this big thing about how people will make S3 buckets public and they contain all this sensitive information. There's a very simple way to solve that. You simply do not ever allow your people to create a public S3 bucket. And if they do, you use a guardrail technology to shut that down. In the environments that we monitor, if you try to create a public S3 bucket, that is shut down within about 5 minutes. And it's all automated. There's no human being sitting there clicking and going, oh, that's bad, that's wrong. Let's have an argument about it. The guardrails just do it for you. The benefit of that is it prevents any of this sort of, last minute discretionary creating things that are public. You need this. Now, people invariably say, my teams will never go for that. That automation is scary. And that's true. In a lot of places, this is scary. But even if you only start as a monitor mode, which is not preferred, it's much better to automate these things. Even if you're monitoring that, that's better than nothing, because at least now you're armed with information about areas where you have non-compliant, non-secure configurations. These tools are very powerful, and they provide a great way to kind of constrain environment to remain secure, remain under compliance and security requirements. So we've been talking a lot about the future SOC and all of this, and what I've been really trying to get you to is this notion of the future SOC is not, it's not a room with a bunch of monitors with a bunch of people staring at screens, watching logs tick on by. Eyes on glass is the biggest problem in a lot of SOCs these days, is this mentality of, well, we need lots and lots of people to be watching all these systems looking for attacks. Wrong. You actually need very few people. What you need is you need to automate all of that. You need to turn all of that into code so it can run in the background. Once you've built these automated environments, once you've built these environments that have this by default and by design, monitoring them for problems becomes, quite frankly, easy, because you monitor for any differences. You monitor for the areas where they go out of alignment. You monitor for simple, straightforward behaviors that are out of the norm. And if you've codified and automated these environments, you can rebuild those at a moment's notice. So it's not about the monitoring. It's about the investigation. It's about the collaboration. It's about working with people and collaborating with them to create these structures and then enable and empower development teams and other teams to be able to do their job better. Okay, so security is the code. I want to wrap up here, and I want to talk about last sort of concepts, and then I'd be happy to take a couple of questions. Here we got our DevOps and our SecOps guy, right, riding the unicorn here. So I know a lot of us, the minute you heard me say the word DevOps, you probably thought of this image. If you haven't seen this image, it's hilarious. I forget who did it first. It's been around the internet, and it's a hilarious image. A lot of us in security think DevOps is just this. We have to scoop up their problems. That's not what we're shooting for. We're shooting for DevOps and security starting to work together. First thing is you got to understand security is agility. Agility is security. If you can't make change quickly in your environment, you can't be secure. Okay? You're just fighting a losing battle. The reason attackers can get into your environment is because they can use your own staticness against you. They use your own resistance to change against you. And they use that constantly. Every breach, or a big chunk of them, all follow the same story. Person gets in, they land and expand, and what happens is that there's ample evidence that an intrusion is happening. Tons of data that attacks are happening. People ignore it. They ignore it because they want to stay. Oh, no, we can't change. No, we couldn't change anything. That might cause a problem. And the reason we think that way is because we've built these highly static castle mentality type systems where we believe any form of change is bad, wrong, and will hurt us. When in reality, we need to change faster, quicker, better so that we can rebuild these environments much quicker. Code is discipline. You are never going to be disciplined enough to stop the attackers of today or tomorrow. I don't care how smart you are. I don't care how many certifications you have. I don't care how many brilliant, amazing, glorious people you hire. I don't care how many rooms full of security experts you have. I don't care how many consultants you hire or how many boxes of gear you have in your data center. You will never work at the speed of today's attacks. It is beyond our human intellectual capacity to work at that speed and scale. We simply don't have the discipline. We need the technology to do the work for us. Code is inherently discipline because it either runs or it doesn't. It also allows for constant refining, which I cannot say of human beings. As great as all of us are, we all have bad days. We all fall down. We have bad years. We have human problems. And you can spend an entire career working yourself to get better and be more disciplined, and one bad day and you blow it all away. And that's just what being human is. Technology doesn't work that way. We can refine something over years and years and years, and it gets better and stays better. The SOC of the future uses code at every single level. It codifies everything. And you rebuild environments quickly rather than try to figure out every problem that's out there. This notion of you have to investigate every attack that happens to your company is wrong. What you need to do is know what happened and figure out if it's a problem, and if it's not, rebuild the environment. Because there just isn't enough time to play investigator for every conceivable problem your organization has. You run into problems, you just flip it and rebuild the environment, and code allows you to do that. You definitely cannot do that in an on-prem world. And the last piece I would say is your job is to be a collaborator, to work with people, not to be an enforcer. If you go into meetings and you find yourself enforcing things, you are not going to be the security person of the future. You're going to be something else. Yes, this kind of automation is definitively going to take your job away. So if you're thinking, whoa, wait a minute, if all the code does all the work, what do I do? Well, guess what? You're right. You're going to lose your job, and you're going to get a better one in its place. One that allows you to be strategic, allows you to be more creative, allows you to collaborate with people, allows you to become an enabler for the business rather than an impediment that drives everybody nuts. Because I've been there as a security person. It's annoying when you're trying to tell people what to do, and it doesn't matter how right you are. They're like, don't care. I've been working on this app for 6 years, and I don't care about you and your compliance nonsense. Automated environments are profoundly easier to secure. Automation employs consistency. There's less room for interpretation. That's a great thing about code as an auditor. If you automate your entire environment and it's all built as code, I can audit your code. Now I know exactly what your environment does. There's no debate. It's not a personal opinion. I can look at the code and say, hey, you don't enforce password complexity rules. It's right there in the code. And it doesn't become this, yes, we do. I know we do. I believe we do. It's the code says it doesn't. Again, that it removes that level of interpretation. It kind of is or it isn't. This is the world we want to get to. This is the world where security works, where DevOps and security ops are integrated together, and they're pooping rainbows and eating apples, and all's well is good. This is our vision. This is what your future security operations center is going to look like. It's not going to be that room. It's going to be collaborative people working side by side with DevOps, product managers, and change agents, and being an integral dimension of that team and providing a key set of tools and structures for developers to work within to implement security by default and by design. That's the last of my presentation. And we've got some time left. I'd love to hear some questions. So Marie, I haven't been checking the chat, so have we been getting any questions?
I have not seen any questions yet, but if you guys want to, if you have any questions, feel free to type those in here. While we're kind of waiting, I did have a question for you, Andrew, as you were talking.
Sure.
As you were talking about how security as code, how is that different from some of the automation? How is that different from automation technology such as Swimlane and Phantom? How are those different?
Right. Yeah. Swimlane, Phantom, Demisto, the one that just got acquired by Palo Alto. That's actually a really good question. And there is a difference between the two. They're very closely related, but they're different technologies with a different goal. So what Marie's talking about here is this notion of automation technologies. Phantom is one of the first ones, right? These technologies, what they do is they essentially orchestrate existing tech. So they'll take a firewall and a sandbox and endpoint security, and they will provide a way to orchestrate their interactions such that if something happens here, you can then invoke actions on a different technology. These technologies actually have some value, and they're very useful in some ways, but they are all very much designed for an on-premise sort of mentality. They're structured around the idea that each of your security controls is kind of an island in and of itself, and that you have to kind of bring them together. Now, some vendors have actually started integrating these components directly into their ecosystem. Fortinet comes to mind with their security fabric. They have a fabric where similar kind of thing. If something is seen in one place, you can implement controls in others. This definitely is an important component of automation, and it does have a lot of value. Where this falls apart is this is not an architecture. These technologies are really a component to help tie together products, but they are not a by default, by design architecture. And quite frankly, they tend to create a lot of overhead. If you build a cloud architecture and codify it and codify all of these components and codify their interactions and codify some of the functions between them using the native code and scripting of these cloud technologies, these third-party orchestration products start to become kind of irrelevant. They're not as important. And by codifying the environment, you actually create a much stronger base upon which to operate, rather than trying to tie together disparate technologies to enforce something. You're actually building a system from the ground up to be secure by default and by design. So they're closely related, but they have different purposes. To be honest, most of the cloud environments that you see don't use automation platforms like Swimlane and Phantom. Those tend to be more an on-premise technology. It doesn't mean you can't use them in the cloud. It's just they don't tend to have as much impact in the cloud because automation is so integral to the cloud, like AWS and Azure and what have you.
Great. We had another question come in, which when you were talking, I kind of thought of too. I personally haven't coded since I was in college. So what kind of language recommendations? So if you're a non-coder, what would you recommend people to learn? Because you've just told us now that we all need to at least be able to understand it. So what would be your recommendation around that?
So I had a slide. Let me jump back to that slide. So it's a ways back here, where I actually listed a couple that are pretty important. I would say the big ones you need to learn are kind of right there. Terraform and CloudFormation are the two big automation technologies and deployment technology. You can learn to do things in either one of those. Terraform is much more robust than CloudFormation. CloudFormation is AWS's automation technology. I'd say for deployment, that's where you'd want to start. Then you need to learn a configuration language. Puppet is a little heavy. A lot of people prefer Chef or Ansible. AWS actually has their OpsWorks is actually an implementation of Chef. So that's a configuration automation platform. I would also say then you need to learn serverless functions. So that's Lambda and Azure functions. So these platforms allow you to basically execute functions. So for example, Lambda can allow you to shut off access to something or grant access to somebody. It allows you to turn on access to certain machines. It allows you to send an email to somebody if something happens. Lambda and these other functions are super powerful kind of doers. So that, I was talking about those like Phantom and Swimlane. You kind of think of these serverless functions as really kind of the same thing. They are really like an orchestration capability. Learning containers is not a bad thing, although I'll warn you, Kubernetes and Docker is like a whole life in and of itself. I'd also say you got to learn some of those base languages, JSON, YAML. Those are sort of your common languages. You see JSON, of course, is a common language that's used in all of these platforms. So these are the technologies you need to learn, and a lot of these are scripting languages. They're not like Visual Basic or COBOL or something from our the olden days of coding. These are more like scripting languages. So once you understand the core kind of structure of them, it actually gets pretty easy to start working with them on a day-to-day basis. You don't have to learn a super intricate language. It's more about learning just their basic structures and then being able to do all that. I'd also note your classic scripting languages like PowerShell and Bash. Simple stuff, been around forever, super powerful. You can do a heck of a lot with PowerShell. Now here's the thing. A lot of you are saying, oh my God, I need to learn all this. No, you don't. You don't necessarily need to become an expert in all of these. In many cases, this is where you and DevOps really need to work together. If you and a DevOps person can work together on this, it can be a case of they write the Terraform script, you simply lay out what needs to happen in what order. You're simply thinking about it as, okay, I'm going to script out the build of an entire system. What has got to happen, in what order, and how does that happen, and what controls have to be implemented, and what variables have to be dealt with. You have to think like a programmer rather than thinking like a security guy who's like, oh my God, we got to enforce this rule and that rule. You got to think about that as a sequence of the things. So it's not always necessarily about learning the code. It's learning how to talk to a programmer and then work collaboratively with them. Most of the programmers I know in this space, they love to work with security people because it's fun. It's actually very entertaining to do this kind of work. And they love it because it's intricate, it's complicated, and it allows an incredible amount of control over things. And a lot of the developers I know are happy to work with these codified architectures because they know that their architecture is coming out of the gates with all the requisite security controls, and now they can develop within that environment. And that's a much more powerful way to work with developers than trying to come in at the 11th hour. That's a long-winded answer to that question. There you go.
No. It was good. At the beginning, I was like, I do have to learn all of these, and then no, I just have to be able to talk the talk.
You got to be able to talk, and know what they do. Like Terraform is super ultra powerful in what it can do, but you just got to understand how to work in Terraform and understand what the structures are. And I mean, even if you asked me to sit down and code Terraform script, I'd probably be lost. But I know how to work with my developers, and we can build that out. So.
Great. Well, thank you, Andrew. It was a great presentation. I want to thank everybody that was on the phone today. If you have any further questions, feel free to reach out to Andrew. I don't know if you want to flip to your last slide here quickly in case they didn't see that. A recording of this webinar will be available later this week. And please join us for our next web tracks in April. This concludes our webinar. And if you have any questions, like I said, please, here's Andrew's information and let him know. You can shoot him an email. Thank you, everybody, for your time today. Have a great day.
Thank you, everybody. Take care.